I believe that this is one of the most important courses for economics and commerce majors, perhaps in their entire career. And why do I think so? First of all, this is because it helps turning the abstract concepts of economics, business, and marketing into practice using the real-world data. Indeed, the methods that we learn here in this course are extensively used by many organizations. Take a private sector, top banks, small banks, from small to top investment and consulting firms, mining, manufacturing companies, you name it. Government agencies and central banks, from small countries to very large countries, like the Federal Reserve Bank, the Reserve Bank of Australia, the Central Bank of China, Central Bank of Europe. All of these organizations on a daily basis use the methods that are learned from this course, and more sophisticated methods that are based on the knowledge that we will learn in this course. Top international institutions that are the dreams of many people, such as IMF, World Bank, EBRD, OECD, also use this concept. Now, this is not a rocket science course. Yet, sometimes you may find some material difficult to grasp. Well, I'll tell you a secret. This is normal. As some of my teachers and coaches in sports were telling me many times, no pain, no gain. This is an old English proverb, maybe a bit too cruel for these days. Basically, it means that you need to put a lot of efforts in order to be successful in something. My preference, the proverb that I like the most is a different one. It says, if there is a will, there is a way. And I encourage and invite you to get as much will as you can, so that you will find a way to learn every bit of useful information in this course to help you be successful in all your life. Now, please see more details about the course in my welcome message on the blackboard, which I usually will call with BB. And also in particular, read the ECP, which stands for Electronic Course Profile. Read it carefully to understand how this course is structured and what are the assessments, the rules, and so on and so forth. And also please check regularly the updates on the BB, on the blackboard, which will be a very important tool of our communication throughout this course. A little bit about acknowledgement. In this course, I used a lot of material like graphs and tables with permissions from the textbook, which I certainly recommend to get, because this is a required textbook for this course. At least get access through the library so you can learn. Many of the material that I will use here is also from other places used for academic purposes, from published papers, including my published papers and others. And what I will be trying to do is to cover the essence, but you're still very strongly encouraged to read the textbook, because there are a lot of useful information that describes the same material more extensively and very useful. That's basically how I learned. Besides the lectures, which are guides and workshops and tutorials, a very important part of learning is reading the textbook yourself, and of course doing a lot of exercises and so on. Now, any feedback to this course, to these lectures, or in general, is very, very welcome. All right, so what is this lecture about? This lecture will be basically an introduction that will be based on chapter 1, 2, and 3, and most importantly, chapter 3. But before you get to chapter 3, it's useful to also read, at least quickly, chapter 1 and 2. And the idea of this lecture would be to prepare you for better understanding of the next concept that we'll be discussing more extensively throughout the course, in the workshops and tutorials and so on, and also help you to prepare better for your self-study. There will be a lot of self-study if you already read the course profile and my welcome message. You must have realized already there's a lot of self-study where you will have to in fact prepare well before you come to the workshop by doing the pre-workshop quiz, starting from well in advance, like a week in advance usually, before you come to the workshop. And each of those pre-workshop quizzes will give you some valuable knowledge, and also you will earn points as you go towards your final grade. Now, before we talk more about statistics, it's useful to clarify that there are at least 3 meanings of statistics. In particular, the same word, statistics, refers to the set of numbers describing a phenomenon. For example, about economy. It could be economy of Australia or economy of China, United States, any country. Or it could be referring to formulas or estimators, what we call. These are formulas that involve in the data to estimate or approximate a parameter of interest. And yet another, and the broadest, the most general meaning that we will use very often is that statistics is a branch or field of mathematics concerned with extraction of useful information from a set of numbers. Now, while statistics is a field of mathematics, the mathematics that we will consider here, because it's an introductory course, is relatively simple. It's quite simple, I would say. I'm sure all of you can get it even more complicated mathematics. The idea of this course, it will be introductory, so it will be, in a sense, easy. If you're interested in the more, I will recommend you more advanced courses later on, and there are many that are offered in this course. At some point, maybe some formulas will be maybe a bit more difficult than others, but don't worry, you can all do it. Just put enough efforts, enough time to understand it. You're all talented, very talented, you're all very smart, you all can do it. Now, let's talk about the idea, the philosophy of statistics. The philosophy of statistics is basically based on what we call the analogy principle, the analogy between population and samples. So first we start thinking, whenever we want to analyze something with statistics, it's about population. There's always some population on the background that we try to analyze. We'll define it a bit more precisely later. But examples could be, for example, all people in Queensland, if we want to analyze people, or this could be some particular characteristics of people, their income, for example, or their education, or their skills, their productivity, for example. It could be for any countries, or it could be for not necessarily people, it could be animals, or it could be a virus that we can try to understand the population of the virus. Or it could be products, or their characteristics of products. Basically, it can be anything. What's important is that we have to think of this, that there are always some laws, what we call laws, or rules that govern that population. This could be natural laws, biological laws, or physical laws, or it could be social and behavioral laws. Often we don't know them exactly. Sometimes they're derived by physicists, mathematicians, or biologists through some formulas. Same thing in economics, but often they are still just approximations of the reality. And often parameters of those, exact forms of those functions, maybe not known, that needs to be estimated. And that's the idea of statistics, that we would then try to estimate those parameters of interest of the population. The simplest examples of those parameters could be mean, variance, but it could be more complicated, like demand function, supply function, and so on. Now, often we don't observe all the population, only some part of it. And that's what we call the sampling process. It could be one sample collected by me or you or any company, but it could be another sample that somebody else collected, and then another sample. And you see, every time on purpose, I use different colors or different shapes to indicate that usually, even if it's the same person takes samples at different points of time, those samples could be different from each other. But then the question is, which one of them is a better representation of population? Which one can we rely on? Any? All of them could be given different numbers. Often we have only one, but the idea is that, well, it's only one that was taken at a particular time. How can we rely on that? Because it could be a different time, could be completely different information in the sample. Well, scientists have thought about this very well and developed what we call the probability theory, which is a very important branch of mathematics that lays the foundation for statistics, that justifies the use of samples to study those populations. And we will start learning about this probability theory from the next workshop. And even before that, through your self-study, you will get some understanding of that. What's important at this stage is to understand that no matter how difficult the probability theory is, it is very important because it's the foundation for the entire statistics. Now, I mentioned about this analogy principle in statistics, or I usually mention the analogy principle in statistics. The analogy principle of statistics basically says that the samples are analogs of the population. And whatever exists in the population, whatever laws are written there, which we often call data generating process, formulas, and so on, including the probability laws and distributions that we will learn. All of those things that exist here, even if we don't know them exactly, we might be able to learn about them or about some features of them, at least, from the samples, the analogs of the population. So whatever feature exists in population, usually we can find a sample analog of that feature through the samples, okay? Through what we call, another meaning of the word statistics, through those formulas of statistics, such as sample mean would be a sample analog of the true mean in the population. And same thing, sample variance and so on and so forth. We'll talk more about this concept as we go. Now, to summarize, the idea of statistics is to provide people with reliable tools or formulas to accurately describe and explain the patterns and evolution of some population of interest from its sample. Now, let me give you a broader picture of the statistics. It's a very, very huge area, but basically it can be divided into 4 parts. First part that we will also start with is the estimation. This part is when we want to estimate from the sample some parameters of interest of the population. For example, this could be some relationship between some variables. And we'll talk about examples how to do it. Another area is about hypothesis testing. Besides estimating the relationship, we want to also test whether the relationship is really significant or not. We call it sometimes also statistical inference. Another important area of statistics is prediction or forecasting. This is perhaps one of the most exciting areas that, many of us, since we were kids, always were dreaming how to have that crystal ball that we can predict the future. Is it possible? Well, I'll tell you the truth. To predict the future with 100% accuracy is almost impossible, unless it's not really a random event. But most of the events of interest are often random, and we'll define what it is. And their 100% accuracy forecast almost never possible. But what is possible is to get some reasonable forecast, to get some insights into the future. And this area of statistics is about that. But it is based on what we learned before. We'll talk about this. There will be 2 last lectures in our course, but to get there, we will need to learn well about estimation and hypothesis tests. So get ready and try to learn as much as you can if you want to learn more about prediction and forecasting. And then we'll also have many other courses in the school, in particular about prediction and forecasting. And that will be based on a lot of material that we use and learn here. Now, another area is so-called causal inference. This area is about whether some particular variable, for example, economic policies or actions, can cause an influence on another variable. It's a relatively new area in econometrics and statistics. And we'll talk a little bit about it. And we have more other courses in our school that I can recommend you later on. Now, let's talk about the basic concepts of statistics a bit more precisely. Now, at the very center of statistics is the concept of a model. When we want to analyze something, we always have to think about the population and then a model that describes the population. That could be a set of formulas that describe those laws, if we know them, at least to some extent, or at least approximate those laws. In fact, it's important to realize that all models are only approximations of reality. In fact, the only model that exactly explains the reality is the reality itself. And all other models are approximations of reality. In the words of one of the fathers of statistics, George Box, of modern statistics, George Box, all models are wrong, but some are useful. And the idea of statistics, or beauty or advantage of statistics, is that it helps to figure out which models are better or more useful than others. Now, models typically involve some variables, and those variables are embedded in formulas. So don't be afraid of seeing formulas. Some of you are more inclined mathematically, others less, but all of you should get useful to using formulas, and all of you can do it. Just put enough efforts. Now, variables are usually characteristics of items or individuals, and the observed values on those variables is what we call data. And in fact, statistics is mostly about the data that are data on variables that are part of some models. Sometimes we call the data also observations or realizations. We'll talk about them more. Now, typically it's also useful to clarify what are the definitions of those variables. In particular, what are the units of measurement, what are the time of measurement, and if there are any caveats, or for example, routing error or sampling design, and so on. And we'll talk more about it when we analyze the data. Now, a bit more precise definitions of the key concepts or basic concepts in statistics. We already mentioned population. What is population, to be precise? Well, it's very simple. It consists of all the members of a group under study. Meanwhile, a sample is a portion. Could be a small portion, could be a large portion, but it's a portion of population obtained using some particular ways. And usually it's important to know those particular ways from which that sample was obtained, typically with a purpose of analyzing or explaining that population. Now, I already mentioned the idea of parameters. Parameters is a numerical measure that describes a some characteristic of interest of a population. For example, these are often so-called moments of distribution. For example, mean, variance, correlation, many others. We'll learn some of them this lecture and consider many of them in the following workshops and tutorials and so on. Could be a bit more sophisticated parameters, such as elasticity or a coefficient of some equation or some function. For example, demand function or demand equation or supply equation. This could be productivity score of a company or of a person, efficiency score, that are describing the population. we usually don't see them, don't observe them, and the idea of statistics is to estimate them, use data, and then some formulas. And those formulas, as I already mentioned, are called the statistics, if we call it plural, or a statistic is one particular formula, or what we call a numerical measure that describes a characteristic of a sample, aimed to approximate a feature of the population. So in a sense, remember that analogy principle, a statistic is usually an empirical analog of some feature of a population. For example, it could be mean, the true mean that we want to analyze, the mean of the population that we don't know. We guess it is there, or we know it's there for sure, but we don't know the exact value. How can we approximate it? Well, it turns out, as we learn, a very good measure of that is the sample mean. In fact, it's so good that when the sample becomes very, very large, it becomes very, very close to the truth. And in the limit, when the sample is infinite, then it becomes exactly equal to the true population. And that's the idea of law of large numbers that we will learn later in a bit more details. Now let's talk about data. Let's have a little break and then we'll come back to it in about a minute.